Welcome to our revision summary on terminal speed. So first thing we need to understand then is when we're going to see this terminal speed occurring. Now the most likely question they're going to ask you is either about just a regular diver diving into a pool or a skydiver. So if we look at our diagram of our skydive we've got there are two forces that we need to concern ourselves with. First one is gravity, which always acts down towards the centre of the earth, and the second one is the drag or the air resistance, which always acts in the opposite direction to the movement. Now at the point that the drag force and the gravity are balanced, so when those two are the same size, then our skydiver is going to be falling at what's called the terminal speed. So that just means that the speed stays the same and it won't get any faster. If we look at our skydiver in a little bit more detail now and see what happens at the different stages of his journey towards the earth. So first of all, not long after he's jumped out of the plane, then his speed is going to be increasing and his drag will also increase as a result of that. So the first thing to remember is that as the speed increases, the drag will also increase. Now in that first picture on the left hand side there, what we can see is that the force of our weight or gravity is greater than our drag force. So that's how we know the speed's going to be increasing, because the weight arrow is larger than the drag arrow. So we've got this resultant force downwards. So he's going to be accelerating towards the ground, and as he accelerates, then the drag will also increase. As we move along to our middle picture then, we can see that the drag force has got bigger because of the increased speed, but there is still a slight resultant force downwards. Then finally, when we get to our third picture on the right hand side there, this is our terminal speed. So the force of our weight and the force of the drag are the same, so they're balanced, and as soon as those two forces are balanced, then the speed will stay the same. Okay, so that is what terminal speed is, when those two forces are balanced and the speed remains constant. Obviously, when we're thinking about our skydiver, he's not just going to keep falling endlessly without opening his parachute, because that would just be messy. So what we do see happening is he's going to pull those ripcords on his parachute, and then we're going to see some changes occurring. So when he opens the parachute, what we see is, because we've got that big surface area now that the air resistance will be acting on, then our drag will increase. As soon as our air resistance or drag increases, the speed is going to decrease, because we've got a much larger drag force than our weight. In the next bit, what we'll see is that the air resistance then and the weight of the skydiver will end up balanced again, because what we see is, due to that drag force increasing, our speed is decreasing, and that then leads to less upward acceleration. Okay, so what we'll see is that those forces will once again balance out for our drag and our weight, so we'll reach a new terminal speed, but it's going to be a much lower terminal speed than we had without the parachute. So that means our little skydiver is going to land safely and still be in one piece at the end of it. We do need to bear in mind that when we're talking about this terminal speed, it's not just happening in the vertical plane. So it's not just divers and skydivers that will experience terminal speed. It's also objects that are moving horizontally. So if we have a look at our diagram here, we've got a ship. So in our top diagram, we can see the thrust from the engine is a bigger force than the drag from the actual water. So that means it's going to be increasing its speed. But as we know, as the speed increases, then our drag force will increase. So what we eventually reach is a situation where the thrust from the engine is the same size as the drag from the actual water, and that means that our ship won't go any faster. It's at its terminal speed. Last thing we need to consider then is how shape actually affects the drag on an object. Okay, because as we know, the amount of drag is going to affect the terminal speed. So when you think about any of these vehicles that they want to go really fast, so you know, the Formula 1 racing cars, fighter jets, then they've got this very streamlined shape. So they've been designed to have the minimal amount of drag possible, because that means the terminal speed is going to be much higher. So what we actually find then is if we've got a large surface area, we have a much greater drag force. So when we streamline our objects, what we're doing there is we're decreasing the surface area and therefore decreasing the drag force that the object will experience. And the other one to bear in mind is if we do have a high drag force acting on an object, then we're going to increase the fuel consumption. So we're going to be burning more fuel to drive that same distance just because we're overcoming those drag forces.